Good afternoon, everyone, and thank you for resisting up until now. It's the last talk. I will need to speedrun this a little bit because I will need to catch a train, as probably many of you do as well. And I have some more bad news for you. This will be a little bit of a technical talk, and it will also be a little bit of a repetition of something you have already heard today. Because we all know and love the usual system design. I mean, talking about load balancers, talking about API gateways, talking about blob storages and compute units, and so on and so forth. All that small modules that over the years have become the building blocks of any software product. When talking about system design, we are all accustomed to this module, to these building blocks. But then, a couple of years ago, this OpenAI company came up and said, look, I'm going to throw at you a new product and you will love it. And actually, let me open a little bit of a parenthesis here. ChatGPT is not an AI model, it's not an AI, it's just a digital product. That's the genius of OpenAI. They took something that was famous and useful only for lab rats like me and probably most of you as well, and gave it to the general public. ChatGPT was more successful than any other digital product before it. It was the fastest to grow until 100 million active users. It took about 2 months against the 9 of TikTok, 30 of Instagram, and so on and so forth. Once this novelty became clear to everyone, then every major company in the world said, I want my own ChatGPT. I want my own chatbot. I want something like that that can be useful with my own data, my own rules, my own private network, and so on. How can we build something like this? Well, you have to overcome 2 problems. The first one was learned the hard way by Bloomberg. Do you remember this one? Probably some of you do. Bloomberg GPT came out in 2023, I guess, and it was famous for about 3 weeks before GPT-4 came out. So Bloomberg GPT was at that time the most effective model for financial tasks, like summarizing a financial report of a public company, understanding if an analysis on a company was positive or negative, and stuff like that. It was based on a model built from scratch by Bloomberg and was more effective than the state-of-the-art of that time, GPT 3.5, at those specific tasks. And then GPT-4 came out, and it made it redundant and outdated in about 3 weeks. So if you want to create your own model, or if you want to fine-tune your model, you must take into account the idea that you are competing against guys that have far more resources, manpower, compute, data, and basically everything than you. So building general purpose large language model is not something that every company can do. It's something that probably less than 10 companies in the world can do in a competitive manner. All the rest should either rely on smaller and very specialized models, or use the general purpose model that big tech put on the market. And I do not want to enter here in the debate of open source against closed model. We are talking both Llama and Gemini, for instance. The matter here is building your own model is most likely dangerous if you don't have very, very specific and stringent constraints, because your model will get outdated in in a short time. By the way, like 30 minutes ago, Gemini 2.0 was released, and it already has some new and very interesting features that no other model has. So if you had built your own model like 1 month ago, congratulations, it has already become outdated now. So this is the first problem. You do not want to rely on your own model because that's a very expensive business. You usually want to rely on a general purpose model, and you want to specialize it in a more flexible way. The second issue is this one. This is a summary of a real conversation that some guy had with GPT 3.5, and they asked, what is the world record for crossing the English Channel on foot? And GPT 3.4 replied in a very nice and convincing English that Mr. George Reef crossed the channel in about 12 hours in 2016. Now, the only guy that I know walking on water didn't do it for 12 hours and chose a much warmer place than northern France or southern England to do that. So this is basically a representation of what one of this morning session was saying. GPT is bullshit in the sense that it doesn't have any idea of what is true and what is not. It's just a model that predicts the most likely next word, and not always the most likely next word is the real one. Encapsulates true about the real word. And by the way, I open another side note. That's not the same thing. So people used to take jokes about GPTs or Geminis or Claudes or other LLMs, saying that they cannot reason because they cannot solve this task. Now, you will probably know after all the sessions of today, how a tokenizer works. Well, this is not a problem of the large language model, this is a problem of the tokenizer. If you live in a world where letters do not exist, but words are made of tokens that are sequences of multiple letters that are projected in metric spaces, then how can you know what the letter M is? You don't. But that's not a problem of reasoning, that's a problem of representation of the language. It's a completely different stuff. It's basically like complaining that a Ferrari is not a good car to hang out in Milan. Of course it's not, it wasn't built for that. Yeah. Now, what's the solution? The solution is grounding. That is, taking a general purpose large language model and make it work with data that you know are correct, that you know are reliable, that you know are pertinent to your tasks. And the standard way to do that is with retrieval augmented generation. Now, many of the things I will be discussing today are taken from this paper. So if you want a more comprehensive discussion than the one I will make, please feel free to check out this research. I'm pretty sure that the organizer will share the slides with you after the conference, so feel free to wait for that mail to come. Now, this is a picture taken from that paper that summarizes the classical RAG architecture. So how does it work? The user inputs a request or a task. What happens is that there is a retrieval phase where the relevant chunks of documents are fetched, and then the large language model, the generator, is provided with both the user query and the relevant context as well. This is the basic RAG. This is how we used to do it in 2022, 2023, but then people realized that this basic architecture can be improved in many ways. By the way, let me take a third side note in this session. When you will read the release notes of Gemini 2.0, you will realize that we are entering a period where the marginal returns over training larger and better models are shrinking more and more. So what's next? Well, think about what happened in the past. What happened when we were no longer capable of building more performant chips by just stacking more transistor into the integrated circuit? Well, we put more integrated circuits in parallel. We built more cores. Or we changed the architecture of the integrated circuits altogether. With LLMs, it's basically happening the same. As we cannot improve by just training a larger and better model, we must improve in some other way. For example, integrating new capabilities, changing architecture, or building more specialized models that can collaborate together. Now, what you see in this slide is basically an example of improving on the ecosystem that is integrating more stuff around the LLM. And in RAG systems, you can do it in two ways. You can either improve the retrieval phase, or you can improve the generation phase by post-processing the context that is retrieved. Let's become a little bit more specific. A RAG system is made of two phases. The indexing phase, where you collect all the relevant documents and you process them in order to create a structured knowledge base, and the, let's say, production phase, where users can submit their queries against the system and get the answers. The indexing phase usually works like this. You have a bunch of documents that go through 4 steps in 2 parallel swim lanes. The first path is about getting the embedding. And to do that, you need to clean, chunk, embed each document. The other one is metadata extraction. Metadata extraction means you, usually deterministically, sometimes with the help of an LLM, extract some tags of each chunk of the document. So we can see an example of this, actually. I'm not going to comment on the code, also because most likely I do not have the container running, which I'm going to fix right now. All right, cool. I'm just trying to show you the outcome of this step. I've got a version, a container running Quadrant on my local machine, and if I run the indexing process, that stuff is going to build a collection of movies. So we do have some 300 movies here. And each movie is represented by its title. There is an overview, that is the description of the movie. There is the release date, runtime, and genre. You see this stuff is metadata linked to a vector. This is the embedding of the chunk. If you want to touch by hand how these embeddings work, you can just open a graph, and you will see the representation, a simplified representation in the high-dimensional space where the embeddings are projected. So the idea here is that this central point is exactly the, let's say, the sample that we are analyzing, and these 5 points here are the most similar ones to that sample. And you can explore the graph of similar points, right? This is exactly what will happen once we run the retrieval step of our RAG system. So what will happen is that we will run a query against the database, and it will look the most similar chunks to our query for us. We will ask ourselves if this is really the most effective way to do RAG, and the answer is no, but that's stuff for 5 minutes into the future. Right. So in the design of our system, the first thing we need to take care of is building this document storage. And building this document storage is usually taken care of by a batch process, which can be something that you run on Cloud Run, which can be something that you run on a step function, anything that can, any compute unit that can run a batch process. And this process is usually well represented by either a sequential script or a directly acyclic graph of tasks linked together. It's like something that can be modeled as an Airflow pipeline, not suggesting that you should use Airflow for something like that, but the conceptual model is a directly acyclic graph. Cool. All right. Now, let's go to the most interesting part, that is, once you have your knowledge base, once you have your document storage, how do you exploit it? How do you use it to give relevant context to your generator, to your large language model? So now things get a little bit more complicated, because you have a user input, which first, in any real-world enterprise application, needs to be authenticated against the user. Why does it need to be authenticated? Because a RAG system is accessing information, and you want to be sure that your user has all the rights to access that specific piece of information that they are asking for. Note one thing: the authentication goes directly to the retriever without any intermediate step. That's because you don't want to delegate to an LLM that is a stochastic component the authentication part. Authentication has to be deterministic, so you will need to have some check of the user privileges against the metadata of the chunks in order to retrieve the correct chunks. Once again, you do not want to have a non-deterministic authentication process. Right. Then, in other sessions, has been discussed in much greater detail the issue of validation of both the input and the output. This is usually done by guardrails. Guardrails can be implemented by deterministic checks, like regex or any other kind of string manipulation. They can be implemented by supervisor models, which is dangerous because supervisor models can be deceived. The problem as of now is that the issue of large language model security has not been solved yet. That is, for every countermeasure that you can deploy, there is some kind of attack that defeats that countermeasure. So the attacker has right now the upper hand. It's like in World War II, at the very beginning, people that were on the attack had the advantage because they had tanks and airplanes. In World War I was the other way around because they had trenches and machine guns. So the point is, maybe in the future that thing will change. Right now, there is no perfect defense against attacks towards large language model systems. So there are screenshots on the internet of people taking the Amazon chatbot into creating Python scripts, and if Amazon is not capable of protecting its chatbot, will you be able to? Not really, not likely. So here the point is really not putting yourself in a condition where your system is vulnerable. That is, designing your system so that every kind of input that the user can throw at you does not result in a problem for your system. And that's not an issue of using LLMs, it's an issue of building, designing the system. Cool. Now, let's assume that the input has been validated. By the way, maybe I can show an interesting Python package to at least mitigate some issue. It's called guardrails AI. And yeah, it's not great. It has some limitations, but it's basically a collection of checks. Some of them are deterministic, some of them rely on small language models, some of them just call an OpenAI API in order to validate a text input. Right. Then, what you want to do is expanding your query. Why do you want to do that? Because many works in research have shown that a more verbose, a more detailed query results in better retrieval when you use semantic retrieval, that is, when you compare embeddings with cosine similarities. This is also true for generation of pictures using diffusion models. In fact, this is a paper from OpenAI presenting DALL-E 3, and here you see what OpenAI is doing. When they introduced DALL-E 3, they said, we do not have the best diffusion model out there, but we do have the best large language model out there. So we will take the query of the users and we will have GPT-4 at the time expand on those queries before passing them to the diffusion model DALL-E 3. So if you ask ChatGPT to generate some picture, be aware that it will not use your request as you typed it, but it will expand on it using the model that you're using. So right now, probably GPT-4o or O1 or something like this. Cool. And you can do exactly the same in your own system. Then, once again, you can take those expanded query, compute the embedding, and run a semantic search against all the chunks that you have in your knowledge base. But you usually don't want to do that. Not only that, because the issue is, why should a question be semantically similar to an answer? You should really compare an answer with an answer, or a question with a question in a semantic way. And this is something that was proposed actually in 2022, when a paper came out and said, look, you can try and have an LLM generate some hypothetical documents that answer your query, and then compute the embedding of those hypothetical documents in order to compare them against all the chunks that you have in your knowledge base. This approach is called HYDE, hypothetical document embeddings, and was shown to be one of the only stuff that systematically improves the retrieval quality of a RAG system. So every time your RAG system has to retrieve semantically relevant information, it's a good decision to put this other path in parallel to the standard semantic search. You ask an LLM to create a document that should be the answer to your question, you embed it, and you use the embedding of that text in order to compute semantic similarity and to retrieve the most similar chunks. Once you get here, what you do have is two sets of chunks. The first set is retrieved with standard semantic search against the query, the expanded query, and the second one is retrieved by HYDE, that is semantic search against the hypothetical answer. By the way, it hasn't got to be the correct answer. It doesn't matter. The only relevant stuff is that is similar to the correct answer. You are always using your documents to provide the answer to your user. You're not using the hypothetical documents. So you're here, and you have two sets of documents. Now, there was another paper that I should have somewhere, like here, that showed that not every place in the context is created equal. So the large language models, even the most modern iterations, are sensible to where a piece of information is inside the context. If it is at the beginning or at the end, it is easier to use for the LLM. So what you want to do is to remove not relevant information and to reorder, to rearrange the chunks that you have extracted from your knowledge base. How can you do that? Again, there are many methods. One is using ad hoc models, like the re-rank from Cohere, which is not open source, or Colbert, which is open source. Another possibility is just to craft a prompt and call a general purpose large language model in order to do that. Why would you need to do re-ranking if you have already done semantic search that is giving you a rank? Can't you just use the initial rank? No, because semantic search relies on the full embedding of the chunk, which is much less precise than how an LLM can interpret every specific token in that chunk. So, good. You have two sets of chunks. You go through the re-ranker. You have only one set that is ideally a subset of the original ones, and it is ranked in the correct way. Now you provide everything to the generator, which is again an LLM, and you validate the output with some other guardrail of your choice. And finally, you get the final response. What's left? Observability. So there are lots of non-deterministic components in this system, and you do not want to throw to production something like this without having a clear understanding of what's going on. So ideally, what you want to do is to track every interaction between your system and internal or external large language models. How can you do that? Well, observability has always been a problem in software engineering, and people have already come up with a great solution that is called OpenTelemetry. So why should we reinvent the wheel? Well, we shouldn't. There are many frameworks based on OpenTelemetry that you can use. There is OpenLLMetry, which is very hard to pronounce. There is OpenLit, which is easier to pronounce, but less mature. And there are also frameworks that are both that are in part open source and part commercial, that are not compatible with OpenTelemetry, like LangFuse. And what I'm probably gonna do is showing you an idea of how one of these frameworks work. So we have something that resembles the full maybe I should zoom a little bit. The full architecture that we have discussed before here. It's not a big deal. It's like 200 lines of code, not a lot. And we see that we have this weird line here. We do not use the OpenAI SDK. We use a wrapper. We use langfuse.openai. What happens here is Langfuse took the OpenAI SDK and basically monkey patched all the functionalities in order to add some tracing to those API calls. So every time we call OpenAI, either by creating embeddings or by asking for chat completions, Langfuse is intercepting these calls and is logging them to their systems. It's exactly the same stuff that OpenTelemetry does when you instrument your own application. And we see that it's as easy as including the @observe decorator on every function or method that we want to observe. If we run this, we will see lots of logs. So here the RAG system takes a query about the movie I want to watch and tries to provide me with an answer containing a good movie for me to watch this night. I'm a very naughty user, and I immediately go for a query that contains violence, like I want a movie that talks about killing a king, which is not something our system is designed to handle, because we have a guardrail to check if there is violence in the query. The guardrail is working because it failed. So the query contains references to violence or hate. And our application is very well designed. When this happens, we print a log and we move forward. So we process the following steps anyway. We have the query expansion, and we see that it's basically a much longer description of the movie based on the one I provided. And then we have the hide query, that is the overview or the plot of a movie that talks about killing a king. We have the two retrieval steps, and then we have the re-ranking steps that only provides us with one movie that's called restoration. I have no idea of what this is. And then we have the final answer. It's not really important how the system works. What I wanted to show you is that if I go to Langfuse and I log into my project, I do have a trace, which is today, and I see, let me zoom in a little bit. All right. I do see every operation, every interaction we had with OpenAI, with its cost, the amount of token that we exchange with the platform, and we should have exactly the prompts that we used. For example, this is the expand query prompt that is what we have, let's say, configured in the system. You have been given the following description of a movie, improve the description with more details to make it more informative, only answer with the improved description, and this is the answer from OpenAI, right? So this way you can have like sensors in every part of your application, and you can understand everything that's going on for every interaction your users have, right? There is more, because Langfuse also allows you to store prompts on the cloud. So in our application, we did hard code prompts in our code base, but imagine developing a mobile app. Every time you want to perform a release, you have to go through the App Store validation process, and it can take days. You don't want to do that every time you change your prompt. So you can store the prompt here and retrieve them from your application using an API call. So if you want to change the prompts or even to A/B test your prompts, you can just use like over-the-air updates and everything will work. Of course, prompts have versions, so you can roll back and do all the usual stuff. I would like to leave some space for questions. So I think that this is pretty much it. I am Emanuele Fabiani, and I'm an AI engineer at Extreme. We develop AI solutions for scale-ups and corporates. I'm also a professor at the Catholic University of Milan. I will be teaching AI in the master's degree in economics and management. I love going through Europe, talking at conferences. So if you have any feedback on this session, please feel free to share it. You can find me on LinkedIn. This is the QR code to my LinkedIn profile. It's not a phishing attack. You can try it if you want in a protected environment.
Okay, thank you, Emanuele.